Alright, impulse. We introduced it in the last video where we said if delta t equals delta p. We'd already looked at delta p. Two things collide, there's a change in momentum. One momentum might be increased this way, other one decreased the other way. And we actually ended up the video by saying if we divide both sides by delta t, then we can say F equals delta p, I shouldn't have cancelled that one, divided by delta t. So force is the rate of change of momentum. Now that formula might look a bit strange, but you've seen it before, because what we're saying is delta mv over delta t is equal to force. But mass stays constant, so we can take it out and we can say that force is equal to mass times delta v over delta t, which is equal to ma. We've seen that for a long time. So what we're saying is that force is rate of change of momentum. So the quicker your momentum changes, the more the force. Now this is going to come up again and again in questions. Okay, if I'm in a car and it's racing along at, I don't know, 200 kilometers per hour, really fast. It's got a momentum. I can convert that 200 kilometers an hour into meters per second. What do? I divide by 3.6. I get my meters per second. I don't know, it's about 60 something. And what I do is I go, wow, the mass of the car, 1200 kgs times 60. That gives me momentum. It's huge. Now, if that momentum, if the car stops and v equals 0, then that change in momentum, let's figure out the momentum. This is 1200 kgs. Now, 1200 times, let's see, what was our velocity? 200 equals divided by, actually, let's do that again. 1200 times 200 divided by 3.6. And we've got the 66,666. Kilograms meters per second. Now that's our momentum. Now if a force is applied, that momentum can be changed. This is no longer conservation of momentum, alright? It's no longer conservation of momentum. Big force is applied, momentum changes. Now when it goes down to 0, that means the change in momentum is equal to 66,666. And that's equal to F delta t. So if that all gets done in 1 second, the force would be 66,666 newtons. Huge! But if it gets done in 100 seconds, then it's 100 times less. So the amount of force is totally determined not by your total momentum, but how fast it is applied. So you can stop anything with the smallest force in the world if you give yourself long enough. So when you slow down gently with your brakes, the force is very small. When you hit a brick wall, the force is huge because the momentum is lost very quickly. Delta t is very small. So when you answer these questions, you always write the formula and you explain. Change in momentum is the same. The collision or the change in momentum happened over a much shorter period of time. Therefore, the force was much greater. This is all about impulse, and you'll see it in many guises. You might see it in how does a crash helmet work? Well, your head goes from 50 meters per second to 0 with the crash helmet. It takes a little longer for the collision, and therefore F is smaller. So always write that formula when you're answering these questions, thinking back to questions. So F delta t equals delta p might be if a boulder whacks into a fence, right? Boulder running down a hill, you got this hill and you got a fence. Boulder's running down towards it, okay? If the fence is very rigid, is the force greater than if the fence can bend? Well, the momentum of a big block running down the hill is constant. It's all about velocity and mass, not going to change. But if the one that gives to stop that block takes a little bit longer, then the force is going to be less. So the bigger force is when the collision is quicker. or the delta T is smaller. So you see this question in all sorts of guises. It's like I said, the guy sitting there with the crash helmet on, right? He smacks his head into a brick wall. That little bit of compression in the helmet slows down the collision. His head's going at the same speed whether he smacks into a marshmallow or a brick wall. But with a marshmallow or with a helmet on, it all takes just a little bit longer and the force is decreased. No brain damage. Use the formula for impulse to answer these questions.